Yo, what's up, everybody? Welcome back. Today we are working on my path planner, and today's topic is trying to avoid making our paths that we planned too zigzaggy. So, context is I use Google Maps to sometimes plan how I get from one place to another, as people do. And I bus frequently, and when I ask Google Maps, hey, I would like to go from one place to another place, he goes, hey, how about you take these 3 buses, and hopefully your transfers are on time, and you better leave right fucking now, or else you're in trouble. And so I don't like that. I don't like that, like, if I leave 5 minutes later, I have to wait 30 minutes for another bus. I don't like that if a bus is a little bit earlier or late, then I miss a transfer. It just kind of like, I feel like it's just doing something like fundamentally wrong, right? And so what I wanted to look at is I wanted to try building a path planning algorithm that takes reliability, consistency into account, as well as like knows that I have legs. Google Maps will like always tell me to wait for a bus instead of walking 4 blocks. And it's like I can just walk 4 blocks. Like I'm not like I have legs. I have legs. I can make it. And so, yeah, the idea is that like we want our path planning algorithm to have a bunch of tunables that kind of express things that we care about. Maybe I don't want to walk uphill today. Maybe I want to take the bus more than I want to walk. Maybe I feel like going for a jog, and so like the timings are gonna like kind of adjust if I feel like I can go faster today. There's all sorts of like things that we can tweak about the algorithm. Maybe I don't want to walk through certain areas at certain points of day. Maybe I don't want to walk by busy streets. Right? Lots of stuff that we can kind of do. So that's kind of like the context. Right now, we have like a rudimentary path planner. So we have all this data scraped from OpenStreetMaps, and you're seeing like on the fly path planning here. There's a red line here, and he's saying like I want to go from here to here, and he's like doing like an okay job. He like that is a valid path. But what I want to work on today is I don't like the fact that it feels kind of like arbitrarily zigzaggy. So if I want to like start from here and I want to go like up here, like I don't really like this route where it goes like up, right, up, right, up, right, up, right. I'd rather it like pick something that says, okay, just go right first, then go up, right? Like in reality, I'm not gonna like when I'm looking for directions, I don't want to do this. This is silly, right? And so I wanted to look into the concept of like adding like maybe momentum to the like path planning algorithm, or if that doesn't work, like maybe looking at something like street based. So my initial thought was like, hey, I'm gonna be like on West 15th Avenue, and like this is going to have like a way associated. We have like kind of like chunks of things that are connected to each other. So here we have like connected. This like blue line is kind of showing all one thing. But it kind of sucks because as soon as you hit like a roundabout or something, this like gets broken up. So these like 2 pieces of like 15th Avenue are like, oh, that was a bad example because it happened to be right on the break of like east to west. But like they're not like really like super like one street isn't one long street, right? Like here, it's only 2 blocks. And so like trying to go, okay, going by like chunk of nodes, that doesn't really work because like now all of a sudden every 2 blocks we're gonna have the same problem. Then I was like, okay, but like the difference between here and here, they both have like East 13th Avenue written here, which is great. However, if I'm walking, I don't want to walk on the middle of the street. I want to walk on the sidewalk, right? And these sidewalks don't have names associated with them, so that gets kind of tricky. Then I was like, okay, so what if we didn't use like these sidewalks, but we used streets that say that they have sidewalks associated with them? That would work, I think, except for the fact that like if I want to walk through the forest here, there is no street. All I have is that like I am a highway path or something, or like like it's not, it doesn't really feel like clear to me that that concept would work. Maybe like high, because like there's like, yeah, highway path maybe is different than like highway footway, but then like discarding all highway footways might accidentally remove some of like these. Like, yeah, here's a highway footway that has no street associated with them. So we need highway footways. We need to be able to walk on highway footways, and we need to be able to like keep going in the same direction. So if we were to take a street-based approach, saying like I want to like, because that's how like I would think about it in real life, right? I would think like I'm walking down West 21st Avenue, and I'm gonna keep walking down West 21st Avenue until I see Highbury Street, right? Like I would, that's how I would do it. But um, how do I say this? So the fact that these like the sidewalks are not connected means that you would have to do some sort of like, if I am on a sidewalk and I'm within some distance from a street with this name, and it gets like all sorts of like complicated. So I think a simpler solution to start with is, what if we just try not to turn? just try not to turn. Okay? And this sounds simple at first, but I think it actually becomes like a little bit complicated because right now, the way if we like turn on like debug path planning and we just start planning a path, these red dots we see are all of the nodes that we looked at as we tried to plan the path. And an important detail here is that every node is like unique. And if we come back and we see the same node from another path, like if we like say we have like something like this, where we have one node that we start from, and this node's like kind of far away. This one's pretty close, but then we're trying to get to here, and this path kind of has like this like long windy way to get here. What's gonna happen is, hold on. Maybe this is a bad example. Let's say that these are connected as well. So what? It's a bad. It's hard to draw out exactly what I'm thinking. But basically, like we might hit the same node from multiple paths. Like say maybe we're like we can come from here, we come from here. Maybe we like come here first, we go here, then we come from over here, and we also go here. Like we can like check that this node is not like we've already seen it, and we already know like each node has like a consistent path or like has like a right answer. Kind of like there is one unique way that is the fastest way to get here. Or maybe there's like two ways that tie. But like this is like a uniquely identifiable thing with a correct answer. Now, all of a sudden, say we have a square. We have a square. And these are all length 1 and we're trying to get here, right? Now, what happens is this node, if we're trying to do like add momentum, going up here is better if we're coming from here, but if we're going right is better if we're coming from here. And so now all of a sudden, like this node doesn't have like an individual correct solution because the correct solution depends on what came before it. And so what I was kind of thinking was that it probably makes sense for our path planner to kind of store nodes as a pair of which node I am and which node I came from. That should be unique, right? Like there should be one correct answer for that pair, I think. And I think that like this basically turns our like 2-dimensional grid that it has like dimensions of x and y into like this like 3-dimensional grid of x, y, and the third dimension is like where I came from, kind of. I think that probably there's some way to visualize this as some sort of like 3D graph in some way. And so then like you can kind of think of this node here is not one node, but it's 2 nodes. It's one node that is that position from this direction and another node that's that same position from this direction. And I think that A star should be able to path plan through that like 3-dimensional space, I think. So then all we have to do is like add a cost to turning, which I think should be pretty easy. So we'll see if this like works. I don't really know if it will, and I also don't know if it's going to become like so fucking expensive that I don't know if it's going to become so expensive that like traversing the whole graph is going to be a problem now, because now our space is no longer like number of nodes, but it's number of nodes times average number of neighbors. So maybe the average number of neighbors is low enough that it becomes like kind of like 4x or something, but maybe it like is like exponential in some way. I don't really know. I have no fucking idea. So let's just kind of like start typing and see what happens. Start typing, see what happens. That's the classic around here. We don't think, we just type. Yeah. So right, also initially, or I shouldn't say initially, at this point in time, we have a path planner, and he kind of works by storing scores for each node in this like array that he indexes directly by his node ID. I think probably pre-allocating the whole array doesn't make sense anymore, because there's probably going to be a lot of combinations of things that we don't look at. Probably the vast majority, I would assume, that we don't look at. Or maybe like that memory cost is like too high, or like I don't know how to calculate it. So I'm going to replace this first with a hash map, std auto hash map of like score key A star node. A star node sounds right to score. And then here we need to have some sort of like A star node, which I guess is something like a like who we came from. So like me is a node ID, and like came from is a node ID. Yeah. Yeah. And then I guess this is kind of like the same thing. Any arrays that we were previously indexing by node ID is just like not fair. So this came from also is a star node mapped thing. And this maps to another a star node, I guess. Yeah. Yeah, because when we're backtracking, we can't just say like we can't just say this node came from this node. He kind of has to say like this node came from this node who came from this node. He kind of needs to like walk it back that way. Which I think is fair. I think it's fair. Now the question is this came from go away? No, it doesn't, because we have to, because this pair is gonna maybe have come from this one, but this is gonna have come from this. So they do have to kind of like map like 2 to 2 type things. I don't know, man. We'll see. Okay, so actually maybe we start. Let's start by not changing anything. Let's just change the data types. So a star node will just say me for now, and we're gonna have all sorts of like compile errors that come out of that, and then we can kind of tack on the extra shit in a second here. But let's start by just like doing the lowest amount of things we can change, which is just to hash map, and then we can like compare them that it still works after, which is chilling. So maybe we'll say a star map is this. I don't know. We'll call this like a. I guess we'll call this G scores and came from. Sure. That way I can use them by name down here, and I can say G scores in it with our allocator. It is kind of silly to store the allocator over and over again, but it's fine. Like relative to the cost of everything else, it doesn't fucking matter. But we could use unmanaged, but I don't want to deal with it right now. So error defer G scores D init, which means that this has to be variable. And then here instead of G scores dot start value, we're gonna say G scores put start dot value 0. Yep. And then here we're gonna do something very similar for came from, except came from is not gonna have anything put, and he's gonna be came from. Okay. And this expects an a star node, so we'll just say me is equal to this. Okay, he still doesn't like that for some reason. Because this is be strong typed node ID. Expected to still not happy? Really? Really? I'm not seeing it. I guess we'll find out in a second when I type zig build. Found U32. Oh. Oh, I'm an idiot. This is me is equal to start. Oopsies, I just wasn't paying attention. Was not paying attention. And then this is 0, 0, like this. Error unit is ignored, so we try. And we're closer. So now we have down here, this came from thing needs to be here. We're saying, hey, I like when I reconstruct the path, I want to look at my end value. But now my end value is like not necessarily sufficient. I mean, at this point it is, but in the future it won't be. Maybe it makes sense to take in the end here as an a star node, which means that here we can kind of say iterator is equal to end. Then the rest of this kind of works itself out, except that this needs to be came from get, which is like this. Okay, which means that reconstruct path now has to be pushed in with something that we look at here. So here we're saying, hey, if we have this thing is the end node, which means that the queue here needs to store the node ID as an A star node, not a node ID. Yeah, that sounds right. Then we add me is equal to start as the first place. Yep. No field name value here, which makes sense. This is me dot value is equal to end value. So if we are the end, then we pass in current node ID. Perfect. Perfect. He's mad because this should be while it me dot value is not equal to it start self start value. That's fair. We append this thing, which is, I guess this is just the node, the raw node. Like when we return the path back to the caller doesn't care about this like unique to from thing. He only cares about the node itself. So here we're going to say it me. But we're going to get the thing based off it, the IA star node, which makes sense as well. And here we will assume that we will find the thing that we asked for, because we shouldn't be able to get here without finding the thing we asked for. Get neighbors is the neighbors for me. That makes sense. No field name value here. So this is G scores is going to be get the current ID. And if this is not there, we're going to call it get or put value. I think this makes sense. And here we can put stud math inf, I think is what we were supposed to put there. I'm pretty sure if we like get diff, our initialized values, initially we memset everything to infinite. Yeah, we did. So this is chillin'. Can you just change the distance function to penalize the changes x or y direction separately? I think that I don't want to do that either though, because there's no guarantee that the grid is axis aligned. Right? Like if we go down here into downtown, everything's on an angle. And so I don't think it's fair to like try to work in like XY space. I think that's kind of like a hack. I think they call that Manhattan distance. And it is something I came across. Taxi cab geometry. So that is a thing people do. But I don't want to, because this is not that. I mean, you could maybe find the axes of your grid, right? You could in downtown discover that you're rotated by some amount, but fuck that. I'd rather just try to do it generically first. If we find out this is shit, then we can always fall back on that. I also don't know if you asked that like 10 minutes ago, because I haven't been reading chat. My bad. Okay, update neighbor. He's expecting node IDs and he found A star nodes, so that makes sense. So these update neighbor. Ooh, let me think about this. So we look at all of our neighbors and we want to update their value like they came from us. So this is going to be like neighbor ID is going to be me is equal to neighbor for now, but eventually this is we're gonna have to shove in the from here as well. But this is fine for now. And we are current is probably also the A star node, I think. We'll see. This will become more apparent as we go, I guess. Okay, this expected F32 found error out of memory. Because this is we tried probably. Okay. Expected type F32 found hash map unmanaged. What? Oh, does get or put value not return what I think it does? It returns an entry. So this entry needs like this. There we go. Except this has to be like maybe this. Okay, cool. Now we have some things that is like confused because it expects node IDs and he's finding A star nodes. So our tentative G score. This is going to include something at some point, but for now we're just going to write me. That's fine. G scores is going to come from G scores get neighbor. And I guess here we need to say that like get neighbor. We need to do the same get or put value. Probably. So I'm just gonna fix me dedupe. I'm not gonna do it right now, but you know, I should. And then this is the same like try value pointer dot star or something. Current score is this. Current neighbor score, I guess we'll call it. Then this is neighbor score. No field name value here, so this is G scores. Oh, if we're updating this thing, then we can actually call this like neighbor entry. And then this actually doesn't need to be fix me dedupe because it's actually like a different fucking concept. So here we're gonna get the thing. And here we're gonna say neighbor entry value pointer like this. And then here we can say neighbor entry value pointer dot star is equal to that. Nice. Nice. Now he's mad about something. I don't know what. So self distance, neighbor, me to end. That seems reasonable. That seems reasonable. So I think that our F scores will probably still use the straight line distance, but for G scores, we'll probably adjust them to have some sort of cost to, like associated with turning. We'll see. But that's kind of how I'm feeling right now. And then came from is this has to be put instead. So this is neighbor comes from current. Yep, that's all fine. All fine. What's he complaining about? Is everything fine? Zig build? No, everything's not fine. Because in app zig 200, we iterate these G scores. We assume that they're array and there aren't anymore. So what were we doing here? We were ripping through the G scores and we were saying basically any G score that has a value in it, we looked at that thing. And here we can kind of say, fuck it. Like here we now can just iterate the iterator. Iterate the iterator. God, I'm a fucking genius. So we're gonna say like G scores key iterator. And we're gonna say while, maybe we just even call this IT. I think that's probably fine. IT next. We'll call this a star node. The a star node me is now we're gonna be looking at here. So we're gonna say if the we actually need the values here too. Let me think. No, we don't. Because anytime we looked at a thing, that means that we were like close by. Like we might be a little bit off here. We might be like logging neighbors here, but that's fine. So here we're just gonna say scene G scores append a star node me. Okay. Which should be fine. We still don't build, but we're close, I feel like. So he's mad about freeing G scores probably in the path planner. In D init here, it should be self G scores D init and self came from D init. There we go. There we go. Okay, so we can find out now how fucked this is. No server running, so very fucked. But we can maybe get a little less fucked if we give it 2 seconds to launch a server. We'll get there, baby. Give him a sec. He's got to think. Okay, refresh. Okay. So nothing looks broken to me. it does look like this is exactly the same as it's always been, which is a big win for us. Big win for us. Okay, so now the thing to do is to try to actually do something. So we'll call this a momentum checkpoint. And in reality, we should check out momentum. Momentum, mo problems. Shut the fuck up. So fucking stupid. Okay. So here's what I'm thinking. I think that we add a static cost to turning. Right? So I think that the amount that it hurts should not be related to the length of the street. I don't think. Right? Like, I think that like this is just as painful as this. Right? I think it has nothing to do with the length of the street we're turning onto. Although you could argue maybe that if like turning once to get onto a really long street is good because there's less turning, but hopefully the turning metric kind of you know, figures that out for us, right? So I think probably we'll say like, I think what we will do is we'll expose to the HTML, or sorry, to like to the HTML, expose to the user. Exposed to me, the only user of this thing ever. We can expose the idea of a turning cost, and we can just kind of do like cross product of us and the other vector, right? So we'll do like this and this, right? This will have like 1, and this will have like 0, right? And so we can just multiply our, like, we will take in like a static cost from user, and we'll just multiply that by the cross product. Yeah, right? Like, that seems reasonable. Maybe. So here, let's say that maybe, how do I want to start this? Okay, let's break this up. So here we said this was, what did we just do? We like split support change data types, and now we're going to be like UI for turning cost. Sure, that's simple. And we can just go to like index HTML, and in here somewhere we'll just be like input type equals text. This sounds like no, I guess it's not text. It's like number. Is number floating point? I sure hope so. Turning cost. I kind of like out of habit make my IDs have no spaces in them, but I guess there's nothing really stopping me from doing this, right? I guess maybe CSS wouldn't play nicely with that. I actually don't know. Turning cost is going to say turning cost. Easy peasy. And then we can actually just quickly refresh just to make sure that like it looks. Yeah, sure, blaze it. I mean, it doesn't look good, but this is there. Andrew's video is amazing about data-oriented programming, by the way. Yeah, that video's sick. Somebody linked me that like a month or 2 ago, and like, yeah, it's a banger for sure. Okay. Then index.js. Here we're gonna have like, I guess we shouldn't copy paste. Turning cost is turning cost, and he's gonna say like turning cost on change on input. I can't remember. I think there's like some subtle difference between these. I think on input it applies like literally right now, and on change it applies like when you press enter or something. I can't remember, but we'll just pick one at random and then get mad later, as always. Here we're gonna say set turning cost, and he's gonna take EV target value. Okay, which means that here in our zig side, we're gonna have to have some function that's like set turning cost. He's gonna take in a float of cost. He's gonna say global app turning cost equal to cost. Sure, which means that we need to define a turning cost somewhere. So here we're gonna say turning cost is a float is equal to 0 initially. No turning cost. I'm starting to get the zig thing. It's pretty fun. Pretty fun. I'll take it. I'll take it. And then when we construct our path planner, here, let's just shove in the turning cost. And then he'll stash it, which is fine. Doesn't really matter. So here he's gonna say like turning cost is a float. And down here he's like turning cost. Turning cost. I really like the try and exclamation mark thing. Yeah, I will say that like Rust's error handling types are like they seemed so good when I started, but it's crazy that like 10 years in, I was still struggling with like what is the best way to set up my errors. It's too flexible almost. So like the zig way is it feels like a much more pragmatic approach where they're just like, look, here's a fucking enum. It's like kind of special. It's baked into language, and like shut the fuck up, just take it. And I'm like, okay, yes, wait, sounds good to me. And then if you want to like tack on extra data to your errors, it's like a little tricky. But that's like the vast majority of cases like you don't need that, and so like having that as a cost you pay at, like in the type system all the time is like not really worth it. I really like just in general. It just feels like they've really thought about like pragmatism, right? They're just like, I'm gonna do the thing that makes most sense for me right now, and fuck any like idealism that like associated with it. Just like keep it simple, keep it pragmatic, and it's like that's sick. Okay, so we have a turning cost now, and so I guess here we're going to adjust now our A star nodes. He's going to say from comes from a node ID, which is going to cause. Wait, before we did this, let's make sure that let's like maybe just log on in it. Turning cost is a number, right? Just to make sure that like we're getting the data where we need to go, or else we'll get confused later when it doesn't work correctly. This kind of like will just confirm to us right now that everything compiles and goes to the right spot, and it doesn't, because of course it doesn't. Because I didn't save. You have to save the code to run it, it turns out. Sometimes I forget that. So we'll go to console here, and we're just gonna hope that like refresh. And here I'm gonna say like 3. The turning cost is 3. And here we say turning cost 3. Let's go, baby. Okay, so everything is as expected. Everything is as expected. And that means that now we can start getting a little crazy in here. So UI for turning cost. And I forgot to write down the time, so that's okay. And now we're actually like implement momentum. Momentum, no problem. I already said that, and I already got mad at myself for saying that. It's just so hard not to. You say mo anything, and it's like you have to say mo problems. Like what else? What do you want from me? Like not to say mo problems? That's crazy. Okay, so is this the only place where we calculate the G score? We just like we have like plus self distance here. We have plus self distance here, but this is for F score. I'm okay with the F score just being straight line distance still. So here I think we'll just probably do like turning cost is or I guess like amount. No, before we get here, let's say came from. We're gonna add the came from node ID thing first. Then we will actually do something with it. Let's start with the we'll start with the scaffolding, then work on specifics. So 37. This is came from. I guess we'll also just say for now that the came from on the first node is just the same node. We didn't come from anywhere. We just like kind of materialized. And I think that won't break anything, but then we need it at 61. So here we add me start came from start. For some reason, like seeing me start sounds like it makes me feel like I'm writing code as Jar Jar Banks. Just like me start. Like I don't know, it just sounds like it's fucking stupid. Came from on this one is gonna be like current node ID me. This is really poorly named, by the way, which I understand. Okay, so that's all fine. And now when we go into update neighbor here, we can say like const amount turn is going to be something like, I think we have like a node lookup points get. We're going to look at the neighbor came from. I guess there's something silly here where we're definitely passing in more info than we need. but that's fine. That's fine. So current came from point. Then we have the like neighbor point is me. Then we have like neighbor point. Hold on. I need to look at a map. If I look at a map, I need to draw. So here, we go here to here, right? This is kind of what we're looking at. And we are trying to decide if that is a good step from here to here. Okay, so we don't have too much information. So we need, right, so this is why, by the way, that is really, really sick. I have different types for vectors, which are like a change in direction versus points. And somebody asked me recently, like, why the fuck do you do that? And this is exactly why. Because I would have just tried to dot product these 2 points together, which just doesn't make any fucking sense. And then me seeing these, like, wait a second, I can't use like a cross product on points. I have to have vectors. It made me realize, oh fuck, I actually need these vectors. And I would have forgot that because I'm a fucking idiot. Which I get, fine. Like, sue me. But, So we're gonna have like the came from, current from is self points get current came from. Boom. Const current is equal to self points get current dash me dot me. This is the current point, came from point. Now we have const neighbor point is self points get neighbor me. And neighbor, I guess we'll assume that neighbor came from is equal to current point. We can maybe like stood debug assert that current me is equal to neighbor came from. Right, this should always be true. But just in case, we don't mind throwing a little crashies every once in a while. Surely Google Maps has thousands of params related to their path plan. I can't imagine what it's like doing to that. I wouldn't be shocked if they don't. I wouldn't be shocked if they're just like neural network, like run this, simulate it, and find the best one by some metric of best. Like that wouldn't shock me at all. Probably not, but maybe. Yeah, who knows what the fuck they do? I don't, so I shouldn't talk about shit I don't know. But you can't stop me. So we'll call this came from vector is going to be the current point sub came from point, current from point, and the to neighbor vec is the neighbor point sub current point. Boom. And then we should just be able to do like came from vec cross to neighbor vec, and then we absolute value that thing. And this should be something, except we need these normalized. Probably, right? Because we want this to be like 0 to 1. So now this is like turn amount. I guess we want like 180 turns to be like really fucking expensive. So abs is wrong actually. We want to do like -1 and then absolute value that. Right? So like if we have this and this, that's no, hold on. Let me think. This is 0. This is 0.5. Sine wave look like this. Look like this. So it's 0, 0, 1, 0, -1. So we have a fucking problem. We have a problem. Right? We want this to be uber expensive as well. So now what? You just want like circle. We want angle. A tan 2? Question mark? A tan 2? That sounds right. So like we have like this and this. Someone else is saying dot, which also makes sense. So yeah, there's two options here. One is like we like try to calculate. Yeah, I did think about that, but then I was like, oh, so I guess we just need like both dot and cross, and we just take so if we dot like I just don't know how like these things add up together. So I don't know if like if I do dot plus cross, is that what I want? Like so here dot product, if this is like forward, dot product big number, cross product small number. Here on a 45-degree triangle, we have like dot product equal cross product. Sure. On 90-degree, we have dot product 0 cross product 1. So if we were to just add them, this would be like root 2. No. This would be, if we were to just add them, this is 2. This is 1. These also aren't 1 and 1. These are root 2 and root 2. So this is 2 root 2. I'm not 100% sure. Okay, but anyways, it's something like it's something like the came from vec dot to neighbor vec. If this is 1.0, good. If it's negative 1.0, very bad. If it's 0, like kind of bad. So we can call this like we can say like one this over 2, 0.5 minus this over 2. That should make it so this goes like 0 to 1, 0 to negative 1. We absolutely value that. So this is like one really bad, really bad, and 0 not that bad. I guess this is really all we need, huh? We don't need the cross product at all. This is just a scale of like kind of bad to really bad. Yeah, I don't know why I thought, because in my head I was like drawing like go forward then turn right, bad. But in reality, we only care about like the projection onto this line. So you guys who were just screaming dot, you were like right, and I'm just a stupid fucking dum-dum. But I would have got there eventually. So, yeah. So dot product over 2. This gives me 1 good, negative 1 bad, linearly between them. And so can we just, is there like a, what's the quick way to get like invert this? 2.0, 1.0 minus this over 2. Yeah. Turning amount. We got there, guys. We got there. Maybe. I mean, I think we got there, but I haven't actually thought about it any more than this. So then we just add the turning amount times the turning cost. Maybe? And so turning cost kind of has to be tuned relative to like meters almost, right? It's like what like a turn, like a full 180 is equally bad to traveling 1 extra meter if that's 1, which is like fine. Maybe. I mean, there's like a chance that that's all we have to do, to be honest. So I guess the previous version of this is like if we just punch in 0 here, we should basically get like equivalent to behavior to what we got before. So if we like come over here and we say like start path planning and we go, instead we get unreachable executed because he's fucking mad. He's always fucking mad. So why? Braces around 1.0 minus dot? I don't think so. Because I was trying to go from negative 1 to 1 to 0 to 1. And so I put this over 2 after on purpose. But I also don't understand, it doesn't seem like this should get fucked. Oh, I guess current node is the length. The length is going to be 0. Um, the length is going to be 0 for the first node because on the first node we are doing me to me, and so when I try to get the normalized version of that, it's going to be 0. I bet you that's it. So here we just say can we even get like, so if the length is 0, normalized doesn't make any sense. So maybe we will say that the came from vec, we have to calculate this specially. We can't use like the normalized. We just say came from vec is equal to this. And if came from vec length is equal to 0, in this case, the turning cost is 0. So if it's not equal to 0, then we do this. And we say this turning cost is this. I think calling it this turning cost makes more sense. Doesn't 0.5 plus 0.5 work too? Yeah, I don't, it does feel like that is more correct. Am I just like fucking stupid? No, because I want to invert it. I want to invert it because I want like -1 to be 1. So I'm pretty sure this is right. I'm pretty sure this is right. But we'll see. You should still make sure normalize and divide by 0. I think that it's not crazy to say that normalized is invalid for a 0 length vector. That doesn't seem crazy to me. Because like, what are you gonna do? Like, I don't know. So I think that if you're calling normalize on a 0 and it crashes, like fine. Like I'd rather crash than pick an arbitrary direction. And if your normalized vector comes out and it's not length of 1, then that's also like fair. Maybe assert then. Yeah, but I mean, like we're effectively asserting already by some metric. It's definitely crashing. Okay, so here is an example of it zigzagging. If we just say like add some turning cost. Fuck. He's slowing the fuck down for sure. Stop. Let's just I guess kill this thing and restart it. So the question is do I think that that's actually doing something? So let's say that my turning cost is 3. First of all, let's maybe turn on debug path planning and see what the fuck is going on there. Oh, so that's kind of interesting. So when you turn up the turning cost, it's like which nodes it looks at are now a lot more like confined, right? If I like reduce this to 1, 0. Oh fuck. I think there's some sort of like fucking degenerate case here where I expect that what's happening. Oh, index out of bounds. That's actually not what I thought was happening. Ad breaks at your streams are like Zoom meetings right in the middle of flow state, come back and I'm completely disoriented for a few minutes. That's so funny. No, I actually don't understand what's going on there. So, is this on? Is it always like that? Unreachable executed, even with 0 turning cost. So this is probably bad. So I would probably like to see on mouse move, do we log like index zig on mouse move? We do try to log this. We used to say moo meant to move problems. Jesus Christ, man. It's so fucking stupid. So yeah, I thought that like this catch here is supposed to log. I guess it's possible that this is not the unreachable that's being hit. We could check that. It could be like hidden somewhere down the stack. In which case, didn't we? Maybe that was in happy hour. We added the panic handler, but then we must have like not saved it because we were like kind of behind. Yeah, let's add that panic handler back. Which I think we should be able to do by like looking at this, and oh, we have to be very careful. String table, index sig. Yeah, there we go. I think that's all I wanted was this little panic guy. Because now when we see that unreachable executed, hopefully we get something that doesn't suck so much as an error log. Reached unreachable code. It's perfect, guys. It's really perfect. What more could have asked for? God fucking damn it. So that's extremely unhelpful. Did I write unreachable anywhere in this path planner? Problem solved. Yeah, it's fuck. Oh, that's so annoying. That's so annoying. You know what? We can probably log. We can assume. Well, maybe we can't assume. Let's maybe go to on mouse move and just here. Let's just log some positions, right? And then we can shove these positions. I was gonna say just out of habit up our ass, but what I should have said was into our native version of the app, and then we can debug with GDB a lot more effectively. So this is like down pause. Then this is our actual pause. And then that should be enough information for us to like. The autocomplete in my brain is for sure broken. Yeah. It's just like you start down one road and you're like, I can't stop it. It's like I see it coming and I know it's not good, but I can't not say it. Like, what do you want from me? Okay. Oh, I guess we want to log. This is a lot of mouse movements that are not useful to me. So maybe instead we can log the view state center. And maybe that's sufficient. Because if we log the view state center, we can figure out how to get there from the native app. And then that's probably just as good. Or we could bisect now. Let's just do that. Yeah. If we bisect now and just don't do the path plan, right? If we just comment this out and the unreachable code stops, then we can just log the path planner state, and that will be way easier for us to punch in. Way easier. And I'm pretty sure that it should be the path planner stuff. Oh yeah, because we know that unreachable is only happening when we fucking hit start path planning. So of course. Okay. So let's do that. We come back here, and we just say std debug log debug, and we're gonna look at dd for number and look at path start value and node ID value. Boom. There we go, baby. We're finally here. Not sure if they would work, but std debug dump stack trace and std debug dump current stack trace. I think I looked at those implementations recently and saw that those are compiled out for WASM, but I'm not 100% sure, so it's worth double checking. Because you're right, that would make an absolute massive difference. In fact, I should just type that now just in case. So it's like error return trace or std debug dump stack trace, and we run this on error return trace. Like, you're right, this is way fucking better than what I'm doing. So we should just do this. If it is possible. Because holy hell, that's better. I'm assuming that this uses stood log, not stood debug print. No. No, this is no good, right? Because we're not gonna have, we're not WASI, and so we shouldn't have this. But maybe we can call write stack trace to an outstream. So if we were to make an outstream around our printer, this would probably work. But that sounds like effort that I don't want to put into right now, but we will put a fix me here. Look into write stack trace. You know, because I think you're right. I think you're right. But, you know, we're already on this path, so here we're just looking for wherever the fuck that unreachable came from. And it's possible the is it possible the unreachable was only getting hit when our turning cost went up? So here we will see this in a second. Hopefully. Oh, my poor web browser. Stop. I guess we stop. And maybe we try. I think that the higher the turning cost, the more likely it is that it's that like our like CPU usage is going to explode, because the number of nodes visited probably goes up with higher turning costs, and then like all of a sudden it's like no good. It's probably something to do with like if the turning cost gets like above the actual distance, I'm pretty sure that will like fuck shit up in some way. Why can't I get our unreachable anywhere? I want to debug it. Please let me debug. Trigger the failure. Oh. Here we go. Let's try this. Let's try this. So if we go into local zig and we say, hey, app path planner, const path planner is equal to import path planner. And we are going to make this thing with this shit. So we need to initialize this with app alloc. What else goes into this? App point lookup points. App neighbors. Then I think the next, no, what the fuck? Neighbor. Hello. Lookup. What is the fucking neighbor lookup called? Adjacency map. Of course it's called adjacency map. What else would it be called? Something to do with neighbors? Obviously not. Okay. Start and end. So start. Value is equal to this. Would you recommend Rust or Zig to someone who just wanted to get started with one? Dude, I don't know. I have to really think about this. I don't know if I would recommend either. That might be like a fucking brain dead take though. But there's a chance that I think that. Like, I don't know if I'm like fucking stupid if I say I would learn with C over both of those. That might just be like the fucking stupidest thing ever. But it does like Zig, you're going to struggle with the idea of like the docs aren't there, right? And so I think that as like a new person to the languages, you're gonna be like, if you're not good at like just like reading code and figuring out what the fuck is going on from that, I don't think you're gonna have a good time. I really don't. And that's like just like that will fix itself in the future, but at this point in time, I don't think that's the case. And so then it's like, okay, then like Rust, I would be interested to hear people's opinions if they've tried Rust as their like first or second language or something. But like, it seems I can't imagine being able to like sit down for the first time I'm learning a language and like figure out Rust. It seems like there's so much like just confusing shit in there. And so it seems like the logical place to start to me is like C, because like it's the only option, right? Like C++ is like I hate C++. Rust is just like there's too much. It's too type theory or whatever, like too like academic. I think, and Zig I think is just not there yet. Maybe even Go is a better like first language, but I've never written Go. It really also depends on like what you're trying to do, right? C is really good to learn. Yeah, I mean, I think that like if you're trying to gain an understanding of like what the fuck a computer is doing, I don't think that like you get better than C as your first shot. Like it's like a nice little balance. All topics transfer from C to others, but not vice versa. That's kind of how I feel too. Yeah, and C, the only problem you're gonna have is like you'll be like, I wish I had an array, and you'll be like, yeah. Well, everyone will be like, yeah, you wish that. But like, I wonder if like I feel like the pain of going through using malloc to write like a vector type is almost like a useful pain, where like I don't think like the pain of writing stuff in Rust is like a useful pain, right? You're not gonna go well, some of it is, but like I don't know if you're gonna be like going from Rust to C and being like, man, I'm sure glad I went through all that pain. But if you're like, if you understand like what's happening when you are using a vector and you're like, oh, it's just a malloc and realix, like that might transfer better, but I don't know. Go is more beginner friendly. I would believe that, but if you're trying to get into like low level programming, I don't know if Go is like the first shot, you know. Rocha, thanks for the prime. Big appreciated. I'd say C is a good first language. It was mine, but it's easy to do something incredibly wrong without realizing. Rust won't compile if it's wrong. Yeah, the only reason I was hesitating with saying C is like when you write like if you write a program a problem and you don't understand like memory management or threading, you're just gonna be like, oh, it broke. You're just gonna be like, seg fault. But maybe like C with the address sanitizer on is like totally reasonable. Like C with the address sanitizer on, it's pretty hard to do something that's like super brain dead to the point where you won't notice. So that would probably be my recommendation. But also don't listen to me because I'm just like a guy. Like, what the fuck do I know? Right? But my recommendation, I would do C. So to answer your question, I reject the premise. Like, should I learn Zig or Rust? I'm like, no. It's like that's not really helpful. That's not what you asked. But get fucked. I get to say what I want. This is my stream. Let's run the pee-pee. And just see what happens. I know C though. Oh, well, in that case, if you know C, Zig will be an easy transition. And then it totally depends on like it depends on what you want, right? I don't know why you would want to learn either Rust or Zig, but their target audience is very different. So just whichever one you align with better. If you're trying to learn it for like job opportunities, it's like 100% Rust. But even then, it's like I don't know if you need either. Like both of them seem like very optional. You know, Dame 2K5, thanks for the prime. I like that. After all of that talking, you're just like, but I already knew that one. I was like, okay, my bad. Jeez, what do you want from me? How do we run this thing? Zig out bins map. And this is using output map data and output map data JSON. I have to be careful with these asides because we're gonna run out of time. There we go. Hell yeah. Here's our little unreachable. Hell yeah, let's go, baby. Dude, working in x86, I'll say it, I'll be brave. Way easier. This is way easier. Holy. It just tells me exactly what's going on. I say learn Rust because it's more different from C. Yeah, I will say that like writing Rust changed the way I like wrote multi-threaded code forever. And I think that's probably a good thing. Where Zig is just kind of like nicer C, in my opinion. Having not written a lot of either. This does just seem like memory corruption. This seems fine. P child, P parent. Oh. This has got to be it, right? Not a number. I don't know. Is this one of those things where right, like here if I look at child and parent, these are valid pointers, But if I go down a layer and then I look at A, then it thinks that it's like cannot access memory. I hit this bug way back in the day where GCC on an ARM v7 processor I was working with, when you ran assert, because it knew that the function was no return, would not track the stack pointer correctly, essentially. And so I spent like 2 days debugging this bug, where it looked like we were getting like heavy memory corruption, but it just turned out that it just wasn't backing up registers. And so I wrote, we had this like assert macro, and I remember writing in there, just push every single register to the stack and then pop every register from the stack manually before that to like fix our assertion backtraces. I wonder if I'm seeing that here, where like the stack pointer is like totally fucked here, but not here for some reason. Like there's something going on here where like here, if I have child and parent and they're like reasonable values, right? These we can like kind of assume that these are valid pointers because we know that me equals came from, or came from equals came from. No, maybe this isn't sane. Me, this came from that. Okay, maybe these aren't sane. I could be wrong here. But the fact that they don't match is kind of fucking odd, right? Like here, we're seeing like A is not child. Those are just different values. And so like that's why I'm like wondering if there's something weird about like stack pointer manipulation going on. I guess it could just be like general memory corruption though. It could also be that I fucked up me and came from. That's very possible. It'd be interesting to maybe in here, can we just log? Like if we just like stood log debug a b. Let's see if this is like lines up with what I was seeing in GDB. Zig build. Rust 1 Zig 0. It's just because there is memory corruption. I've written a lot of memory corruption in Rust as well. I really like that unsafe keyword. And man, does that fuck me. Okay. So this does seem like the same thing, right? I'm seeing that nan, and I'm seeing me 5-5 came from 7-5. Me 7-6 came from 7-5. So the fact that these two came froms are the same feels wrong to me. Let me think for a second. Thinking for a second. I guess that's not true. If this is in the sorting, this is in the sorting of points when we add them to the heap. So this is just like, they're just trying to sort this and this. And that's failing for some reason. Because the F score from one of them is not a number. What's my end node ID? End is this. So it's not like we hit the end and the distance to the end is 0. Why would my F score ever be not a number? That's probably where we should start, huh? So F score comes from G score plus distance. So if G score is not a number, that not a number probably propagates. I don't know if Rust or if Zig is smart. If I go like var a is equal to stood math nan, and I do like a plus b, if I do like const c is equal to this, and then stood debug print c, I don't know if that like propagates or if it crashes. It could be either. Zig, map, and let's zig build and that thing. Let's try to huck him out there. I guess the fact that this is not crashed yet indicates that it's fine to add nan. They're fine with that, but they are not fine with ordering nan, which is totally reasonable. So the F score could have come from the G score. So I guess here, we'll say tentative G score here, and we'll just say if tentative score is nan. Is it like stood math is nan? Hell yeah, dude. Panic. Uh-oh. Uh-oh. Spaghetti-o. Every Rust dev is legally required to show Rust on every occasion. That's true. Steve would beat you up if you don't. I feel that Steve guy is just like a pretty reasonable guy, right? I probably should have rolled GDB. Whenever I see him online, he seems reasonable. I don't think that he would encourage beating. I think that there's lots of people that write Rust that would encourage beating. I just don't think that he's one of them. But what do I know? Okay. So we are probably right at the problem. So we can probably take a little peeky. Frame 7. What, list? Is that how I look at this? We can look at p current score. Well, current score is fine. This turning cost. Oh, that'll do it. So it is the code we wrote caused the problems we see. Who could have fucking seen that coming? Who could have seen that coming? So here we should just move this here. Shocking. Yeah, it's like who would have seen it coming? First time chat, C:*? I don't know what to do with that. What is this symbol? Oh, and you're drawing my username? This is this is like a really shitty terminal prompt. Really shitty terminal prompt. Right? Because like I think like if you look at like a just like old style terminal, like I think that I feel like in movies and stuff you see that like caret all the time. It's not called a caret. It's the like left angle bracket. C drive keys on Windows. Yeah. Perfect. Check the icon of terminal windows on Mac OS. Ah, yeah. Windows PowerShell. Yeah. This is I probably just yoinked it from this. Yeah, I don't know where it's from, but C:* is also smiley face, but then you threw a question mark on there. I was confused. Okay, can we like p self turning cost? This is known. This is 2, so it must be turning amount. Nan, because okay, came from vec is fine. To neighbor vec is nan. Okay. So why is my neighbor point and my current point the same? That's the problem, kind of. I also forgot to normalize came from vec. This should be 1.0. We were supposed to do this. I just forgot. We forgot. But I don't understand. Neighbor point is the same as came from point. Right? That's what we saw. It was current point, not came from point. It must be that we're somehow like No, I don't see it. I don't see it. So this is passing, which is very strange to me. Current point is the point at current.me. Then the neighbor point is neighbor.me. I guess they could just have 2 points that are connected that are on top of each other. I guess there's nothing saying the starting point as came from equals me. I was thinking about that, but we should never hit that node again. I'm like 90% sure we shouldn't hit that. Also, the number that we're seeing, I'm pretty sure is not the right number there, right? I'm pretty sure that we were seeing something that ends in 7.5, and in local zig, our starting point is 3.9. So I'm pretty sure that's not it. I think it's that in OpenStreetMap's data, there could just be points that are literally the same point sitting on top of each other. And that's like valid and fine. And before that just didn't cause any problems because the distance was 0. And now that's just not okay. So I guess in the case that it's 0, the turning cost is 0, and that's totally fine. So we just have to do the same thing here. We have to say if came from vec length is equal to 0, or the neighbor, we'll say this like const neighbor movement vec or something, to neighbor vec is this. And we'll say to neighbor len is to neighbor vec dot length. So this is equal to 0. Came from len is not equal to 0, and to neighbor len is not equal to 0. Oh, no, and it's and in this language. Then we say to neighbor vec is to neighbor vec mol 1.0 over to neighbor len. Then that should do it. That should do it. Let's see. No crashies, please. No crashies, please. Give him a sec. He's thinking. Please, sir. Please, sir, don't crash. Exit normally. We leaked, but that's fair because I think we just didn't free our path planner. Okay, so we should be able to go back into our little JavaScript land and stop getting spammed with unreachables. We want to close this and we want to reopen. Okay. Oof. Oof, you can really feel that. Okay, so this is getting like... I don't understand actually why it's so slow. Like, I would think that it would be slow, but not this slow. So is it like, is it crashing at all? Or is it just like literally that it's so expensive now because the node graph kind of like expands? So I guess we're printing all the time, which is fucking stupid. So that's probably slowing us down a metric fuck ton. But I don't know if it's like a metric, like a as much of a metric fuck ton as I think it is, or if it's just like a little bit of a metric fuck ton, you know? Are metric fuck tons bigger? I assume they are, but I don't know why we say that. And by we, I mean me. I don't know why I am saying that. Oh yeah, okay, cool. That makes me feel a lot better. Oh, turning cost is 0. Turning cost is 2. Okay, so it was just the printing. And now we can probably try to see if like, if I up the turning cost like 4. Okay. So now the question is, do we think that fixed anything? So we can try going like over here, start the path planning here, and just kind of see like, so the turn cost 0. We get some zigzags, and if we turn the current cost up to 1, oh wait, that's kind of working. Okay. So it's not, I guess here, like, oh, interesting. I was gonna say I thought this wasn't working right, but I guess here, because we start in this lane, like, it has to turn to when it gets here. So it's picking a natural breaking point to make the turn on, which kind of makes sense. Yeah, I would think I might be happy with that, to be honest. So 0, he's zigging and zagging. It's really hard to see, I know. Sorry, guys. I need to fix that. 1, 2, 3. Yeah, I mean, I think that's a lot more reasonable. It doesn't, you don't even have to go like that high. Like, can we maybe look and see if like, if we go to like 4. Like, I wonder if you can almost like tune this based off of how the like visited nodes explodes. Oh no, it's just turning this up makes it look at more nodes, no matter what. Yeah, sorry. I know you guys can't see this very well because it's so if I zoom in on this to force the canvas to like be lower res, I wonder if the points if it's like easier to see. But yeah, I mean, so if I pick like 0, I guess that path is like just there's a diagonal there, so he's always gonna be okay. So maybe we can try to like look through an area of the city that has less diagonal, maybe like over here. So I go from like here. Oh, even that, because it wants to get to like this diagonal point. So, I mean, yeah, I mean, you can definitely see that having an effect. Whether or not it's an effect I like, hard to say, but it's definitely an effect. Cool. Oh yeah, that's way better. Cool. Cool. So 2,000 fucks versus 2,200 fucks. A metric fuck ton is indeed larger. The more you know. Perfect. Yeah. Okay. I kind of thought that this was going to be a larger shit show than it has been. So I don't really have much of a backup plan, to be honest. I guess we'll move on to this is really bothering me. This the fact that we can't fucking see the planned path. So maybe we can try making it thicker. That's probably a good thing to do next. Let's do that because I really want to be able to at least like show this without being like, oh, we can't see it. So yeah. The other option is we could implement more cost saving measures, right? So we could look at not cost saving, sorry, like more filters. Like we could look at like saying, oh, I want to work on main streets and stuff, but yeah, I don't know if you know, but we can't see the path. Yeah, sorry. It's really small. I get it. I know. Yeah, let's fix that. I think that makes the most sense. So I'll call this done. JK, it's not too bad. That's fair. But it's bothering me enough that I want to fix it anyways. Because I can't see the path. Like, even, like, I struggle with it enough that I just want to do this. So we'll kind of call this good to go. And then we'll say, thicken path. I would like to see it. So basically, like, what we were doing before was we were trying to call geo line width. But geo line width is not guaranteed to work on WebGL. Right, so here he says, hey, just so you know, like we can set the maximum, minimum to both 1.0 and then you can't change it. In which case, if we want to draw a thicker line, we have to rasterize it ourselves. So the question here becomes, do we want to apply this change to all lines or just the drawn line? Because if we do it with just the drawn line, we would structure this as basically saying like we have like this line we want to draw like this, and instead we'll just draw a triangle strip like this. Boom, right? You would just kind of do this. In fact, you would probably actually do this. Right? You would do something like this. I guess you would kind of even get a little crazy where you would maybe do something like this. Wow, look at that. Something like this. Now we could do this for all nodes as well, And if we do this for all nodes, that means that like the way this stuff is laid out right now, the way it's laid out is you have like point data in memory, you know, like 0, 0, 0, 1, 0, 2. These things are like grouped by 2. And when we draw, we say, can we draw like lines between 0 and 1 and 2? Can you just like draw this line? And we put like an FF to say like stop. And so then that way we can like render kind of like the whole world in one go. So it's like pretty easy to just kind of like work with it this way. Can you emit points in a WebGL shader? I was looking into this pre-stream. There's no like geometry shaders in WebGL, and I think that vertex shaders have to be like one-to-one mapped. So I think that what we would have to do is we would actually have to make each. We would basically have to duplicate each point for each line. So if we have like right now, if we have like point, 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 and we have like these things connected like this, we only store this point one time. But now we would have to store this point 4 times, once per line, and actually more than 4 times. It would actually be maybe 8 times, because each of these points now would become a rectangle, which gets kind of hairy, just like kind of shit. So I actually don't know if I want to do this right now. I'm looking at the clock and I'm thinking like, there's no way I do this in half an hour. This is just going to be too hard. So instead, we end early, baby. So I think what I'm going to do is that will be the focus for tomorrow. I think it is worth doing because it's very frustrating. But I'm not going to be able to accomplish this in 30 minutes right now. The momentum stuff went way better than expected. So it's kind of like I'm kind of in this weird little dead zone. So we're going to call it for today. Thanks for watching, guys. If you liked what you saw, I stream most days at around 12:30 Pacific time to 4 Pacific time. We ended a little early today. And what you see in YouTube videos, if you're watching on YouTube, is really more of like the 2 to 4 stream. So that's, we call the pre-stream like happy hour, where it's kind of like more just like vibes. We're working on like smaller things, not necessarily something that deserves its own feature in YouTube video. But so if you want to check that stuff out, you have to come by on Twitch, or they get archived on Patreon. If you want to if you're watching on Twitch and you want to see what we've worked on, we have our stuff organized into playlists. So there's a bunch of stuff here you might want to check out: operating system, QR code decoder, map time, like video editor. There's some stuff in there if you want to check it out. There's a Discord linked in the Twitch description if you want to get updates about like when I'm going to go live, or like sometimes I just chat about stuff in there off stream. So like the other day I found a fun little pattern for working with like making like a little check target, and I was like talking about that in Discord and stuff. So if you want to like have like off-stream discussions, that's available. GitHub is also linked in the Twitch description. If you want to see code for this project, it's here. I think that is everything that we have to say. We have to ask you guys to like and subscribe, obviously, and Twitch Prime, obviously. But other than that, I think we call it for today, and we say goodbye to YouTube and Twitch. Let's find someone to raid.